Our machine shop, we have 3 lathes. Those are Harrisons. We'll actually have 4. This is a Monarch. We also have a 4-axis CNC machine. Okay. Over here we have, and if you are interested in doing safety training, we have an iron worker, so you can bend and shear steel, a grinder. We have a drill press, a belt sander, a horizontal bandsaw. So all things for shaping material. Back here we have, this is a CNC plasma cutter. So we can put a piece of steel and we can cut out in a controlled manner, steel. We have TIG and MIG. That's MIG, and this is TIG. And now we have, and this is the plasma cutter, and then that's also a TIG machine. Okay. Over here, you guys come over. We have students that are in their senior capstone projects. So Travis is, we have 4 vertical mills, and so on a vertical mill you can basically make another vertical mill. It's a very versatile machine. But like Travis is making parts for. Travis, will you explain this, like what you're making here?
Sure.
So guys, this is Travis.
Nice to meet you.
He's a senior. He's going to graduate in December.
So,
Can you show him this thing?
So this is not done yet. We're still making parts for it, but we are replicating the effect of a $12,000 spherical air bearing, except for a lot less than $12,000, which is why we have these transfer roller bearings. I milled out these little aluminum things on there. We tilted the head of that, which is really obnoxious to do, but it turned out really well. Got the transfer roller bearings mounted that, steel round stock that we got hooked up to a table. We just kind of plasma torched the extra table off of, and functions pretty close to an actual spherical air bearing. Just, obviously a higher coefficient of friction and whatnot, but that's what we were going for. Other than that, we're just machining about 1 million random parts to go on, and we got a sheet metal part that's going to fit and go up across this.
It's a really good sheet metal part.
Yeah, you can handle that. You made it. But got a bunch of these linear rods that are going to be, or these are to hold the linear rods. This we need to touch up a little bit, but this is a 1-to-1 replica of the satellite we're going to be putting on this at the end of this. And I don't have it with me, it's in the cabinet, but we have quite a large amount of random steel stock to make it weigh the same amount as the real one, which is like 50-something pounds. So, and the end result is that's going to sit on there. We're going to have effectively a CNC system to control the satellite in this direction and in that direction. So we got this fork, and from those two we'll be able to co-locate the X and Z locations for the center of mass. And what he's messing with, we got these, which have somewhere over here, not cut out yet, but brass, which we're going to make into weights, which will then go up and down on the Y, so we control it in all 3 axes.
So this is a real project they're doing for General Atomics, and
yeah, they gave us like what, 10 grand, give or take, to make this, and we're absolutely baffled when we got this far with like 2 grand. So, because I mean, just that hemisphere is insanely expensive to machine if you want it actually high tolerance. Like the cheapest estimates I could get from somewhere like Cawthron was, I think he quoted me at like $1,400 to $1,600, and that's if I supplied the stock.
And they did it here in our shop.
It took a lot of convincing and a lot of research, because it wasn't just like, here's a 10-hour endeavor on the Haas, okay, bye. I had to actually, figure out how we were going to do it and help out as much as I could. So that's where we're at. I've been many days doing this.
Yeah, they're making all their parts.
Yep.
Okay. And then this is Colby, and Colby did the welding for them on this sheet metal part. So students, we also have students that help in the shop.
Yeah, we had little stitch cuts along here, and to reinforce it, we had them welded and then just kind of sink it down. So
Cool. Thank you, Travis.
no problem.
So this is our shop. Then over here, we have more equipment. If you see this. Who is this? Can I take Becky and into your lab in a little bit to show them your lab? This is Ulysses. He's a graduate student.
So Here we have a 3D printer and 2 types of extruders. So I do my own filament. I have the ABS pellets going to the extruder and the winder. This is from a fill extruder. Then we have this extruder works with a wood drill auger, so it's more of a hobby level extruder. This one is a little bit more more commercial, we can say, but still hobby level due to the size. It has a actual screw auger for extruders, which is pretty much tapered all the way, so it has more compressibility and better mixing. And what I'm doing is pretty much I'm gonna be mixing ABS plastic with Martian and lunar regolith simulants, or the dust that simulates the properties in Mars and Moon. So we're going to be mixing ABS plastics with that and try different ratios in order to, when there is manufacturing in the Moon and Mars, rather than just sending stuff, they can print their own stuff, and if they're running low, they can mix it up with a dust simulant, or on that time probably that dust, the dust on the local area, and increase the feedstock and wait for the next shipment, pretty much. So what we're going to be doing is trying different mixtures, and then print out what we call dog bones. And it's from HTM standard, and put them in one of the instrons to test the tensile strength and see how the different mixtures with sand, with dust, affects the properties of ABS.
And he's humble too. Ulysses actually wrote all the code, or at least got and updated the code to actually. That's a machine from Stratus and the Fortis 250, but he created all the code that actually moves the machine and does the G code and everything. Actually, and it turns the head on and moves the table. So it's just he didn't. Ulysses did a lot more, but so this is his project. He said it way better. I just want you to know that he actually did a lot more than what he showed you. Okay, and if you come in, thank you, Ulysses. If you come in here, this is our CNCs. So we have 3 Tormach CNCs, and if you would like to learn, or students would like to learn on how to use these machines, we have multiple ways that they can do that. We have the manufacturing lab, which is ME467L. We're going to change that to ME267L, so it's going to be available to sophomores. Now it's just available to senior level class, but in 1 year from now, it's going to be available to sophomores, so they can learn at a lot earlier age. And then also we have advanced training on the weekends, so you can learn how to use some of the, like the lathes and the vertical mills. It's an 8-hour class. Also, if you're interested, you can also we have what's called a shadow program, so a student could work with me or with one of the students, and then when we're working on projects, you learn how to use the equipment, and then we'll put you on the equipment so you can actually run it and learn. So you're learning what, as we're making things. Okay,
so for students wanting to be in ASME, is this lab in particular a great resource for them to come to?
Yes, because the thing is like with SAE, I mean, they live here. That back corner is theirs. You can see all the HPVs. This HPV, this is all ASME, but ASME, these are all the past HPVs that the students have built. And then they're building a new one this year. This is for children. This is a little one that they're doing. But these are your cabinets, and this is all of your guys' space. We just haven't had students over here in a while. But we used to have students that would work in the shop or ASME. This year, SAE, basically, they live there. That's their corner back there. And that's another one. That's a HPV that they made out of bamboo. So what they used to do with that one was they built the bamboo one to raise money with heating up water for top ramen, making top ramen. So what they did is the students came in on a weekend and they made a parabolic mirror, a gigantic mirror with a whole bunch of little mirrors, but it's a parabolic mirror. And they put it on they built a cart and they pulled it with the bamboo HPV around campus. And then they had top ramen soup, and they sold the top ramen soup for, it's like $1, maybe for $2, but you could stick it in the parabolic mirror to heat up the water. So that's something they did. But what I ended up doing is I got a phone call. They were putting 2x4s at the parabolic, setting that on fire. So we stopped doing that. But then what they did is they would take the HPV, when we used to go to Flagstaff Festival of Science, and the little ones would roast marshmallows at the focal point. So we used to do that. Yeah, but all of this space, this is available to ASME students. This is your guys' space, and I'm the shop manager, so plus I'm your advisor. But my point is this is definitely this is for students, and then you guys will also have. So if you do a video, maybe we could also go visit Gia in room 119, because the Ideas Lab is also available to students. We have 3D printers and a laser cutter in there, and we're getting new 3D printers. Okay, and then there's just, and then be careful, sorry, this is a pipe bender, and that's a notcher for bending pipe. And then we've got 2 more pieces of equipment. This is another CNC, this is a FedEx CNC, and then this is a surface grinder. So we can grind steel very flat and parallel. You guys seen the wind tunnel? You guys know
No.
about that? Here, what you guys, I'll show you that, that's where we were. This is the SCE club, they do the ball. But they've been doing that as a capstone versus a club.
Ah.
And here, so this space is also available to students for doing build. But then here is a wind tunnel. So you guys will see this like in a 495 lab. But what we've done with the human powered vehicle is you guys will learn about Reynolds number. So you can take a large object, like here, if you look at here, there's a F-15, I think that is, or F-16 fighter. And you can scale it down with Reynolds number, and if you have the wind flowing over it, you can measure the loads, you can measure coefficient of drag. So you can get a realistic properties about, so like what the students is that they took their fairing design, they 3D printed it, and then we set it up inside the wind tunnel, and we ran it up to the speeds that they were going to see how well their design would work, and then that's how they decided if they were going to use that fairing. Okay, and then this is a water table. This is for another project, but what's cool about it is that the students get to learn how to use a manometer. So, when you have atmospheric pressure, the tubes on both sides are at the same level, but as soon as you apply pressure, one side's going to go up higher than the other, and if you know the density of the liquid that you're using, you can figure out what the pressure is. Okay, that's what I wanted to show you.